Welcome everybody. This is Alper Meşahin and this is my 512 microwave electronics project. In this project, I am designing a low noise amplifier by using ADS tool of Keysight. In this design, we have two main components. And these are the two transistors that you are looking. In this design, we use Cree GaN components. And this is my finalized circuit. As you can see, there is our source. And this is our input matching circuit. This is our bias circuit for adjusting the current of the drain. And this is transistor bias circuit. Also, for the second amplifier transistor, we have the same biasing circuits with some components parameters changed. And at the output side, we have output matching circuit. As you can see, that consists of inductor and capacitor, and this is our output side. In this design, I used S parameters tool. And let me show you the results of this amplifier. And first, I will look at the stability, and I will generate it with this one, from 10 megahertz to 8 gigahertz. We have to have stability, so our circles, stability circles, must be outside of the Smith chart. And as you can see from this graph, Smith chart, our circles are outside of the stability circle, so we can say that our circuit is stable. Also, we can approve it by looking at the stability factor plot versus the frequency I just specified. As you can see, minimum marker is at the around 3.5 gigahertz, and the value of is 1.05. If we have stability factor greater than 1 at any frequency, our circuit is stable. In the second part, I look at the input matching and output matching circuits. So I will change the frequency to a single frequency of my design, which is 5.3 gigahertz. When I run my simulation, I can see the results. As you can see, this is the GS circle, input circle, and it is very close to the center of the Smith chart. And for the load side, let me show you GL circle. I will add it, and as you can see, it is also close to the center. So we have approximately perfect matching both at the input and output side. After that, I will look at the S11, S22, and S21, which are input return loss, output return loss, and gain. Let me run my simulation again with different frequencies, which are from 5.035 to 5.565, which are my operating frequency range. As you can see, our S11 is at worst minus 9 dB. So it is a good input match return loss. For the output return loss, it is minus 21, which is way better than the S11. And for gain, let me show you, our gain at the lowest frequency is 8.7, and at the highest frequency is 11.7, or vice versa. And let me show you, our minimum noise figure is around 4, which when we have perfect circuits, we will achieve this one. But my circuit that I designed is around 5. So it is a little bit higher than the minimum, but it is also okay value. After that, I generate the layout of my circuit, and which is I will show I generated before. And as you can see, this is my circuit. I have adjusted the components and their connections. So it's like this. As you can see, this is the dimensions of my circuit, which is in my microns. So around 3 centimeters to 1.5 centimeters on my circuit. Thank you for watching.